Good day everyone, I am Domingo of BSED 1C, and today, me and my partner Noemi will going to discuss the color of the stars. For our learning objectives, by the end of this session, you will be able to compare the relative temperature of the stars based on their colors. And number 2, you will be able to understand how astronomer uses color indices to measure the temperature of the stars. Now, let's proceed to our introduction. Makikita dito yung figure 17.3 kung saan makikita yung Sagittarius star clouds. Pini-feature nito yung variety of stars with varying colors. Ang ginamit ng mga astronomer na method dito is qualitative para ma-characterize ang star colors at para ma-determine ang stellar temperature nito. Colors and temperature. Wey's law relates stellar color and stellar temperature with blue colors dominating the visible light output of very hot star, and wavelength emitting most of their energy. The color of stars provide a measure of its intrinsic or true surface temperature. Except for the effect of interstellar dust radiation. Sinasabi lang dito na ang color ng stars ay hindi nakadepende sa distance nito, katulad na lang ng traffic signals. Ang color ng stars ay nagre-remain na pareho kahit na gaano kalayo ito. Here are some example star colors and corresponding approximate temperature. For the stellar type, we have O, B, A, F, G, K, and M. For their color, we have blue, blue-white, white, yellow-white, yellow, orange, and red. For their surface temperature, blue has greater than 33,000. Blue-white has 33,000 to 10,000. White has 10,000 to 7,500. Yellow-white has 7,500 to 6,000. Yellow has 6,000 to 5,200. Orange has 5,200 to 3,700. And red is less than 1,700. Stars have varying temperature, with the hottest being over 40,000 Kelvin and the coolest around 2,000 Kelvin. Our sun surface temperature is around 6,000 Kelvin with slightly greenish yellow peak wavelength. In space, the sun would appear white and reddish and blush wavelengths.
However, from Earth's surface, it appears yellow due to nitrogen molecules scattering shorter wavelengths, leaving more long wavelength light behind. This scattering also contributes to the blue sky. And now, let's dive to the color indices. Astronomers measure the color of the star through filters that transmit light from a specific narrow band of wavelengths. The filters are named as U ultraviolet, B blue, and V as visual for yellow, which transmit light near the wavelengths of 360 nanometers and 420 nanometers and 540 nanometers respectively. Color indices are measurements that quantify the color of the stars by conferring its brightness in different wavelengths of color. The purpose of the UV photometric system in determining the colors of stars is to classify and study them based on their spectral characteristics. The UVB system utilizes filters to measure the brightness of stars at three specific wavelengths, which is U, ultraviolet, B as blue, and visual as yellow or green. These measurements are expressed in magnitude, with the difference between any two magnitudes being termed a color index. The brightness measured through each filter is usually expressed in magnitudes, with the difference between any two of these magnitudes, V and V, being called a color index. By agreement among astronomers, the ultraviolet, blue, and the visual magnitudes of the UVB system are adjusted to give a color index of 0 to a star with a surface temperature of about 10,000 Kelvin, such as Vega. So, by conversion, astronomers adjust the magnitudes in the UVB system so that a star with a surface temperature of around 10,000 Kelvin, like Vega, has a color index of 0. So this means that Vega serves as a reference point for defining the 0 point of a color index scale within the UVB system. The VP color indices of stars range from negative 0.4 for the bluest stars, with temperature of about 40,000 Kelvin, to positive 2.0 for red stars, with temperature of about 2000 Kelvin. The VV index for the Sun is about positive 0.65, and the use of a color index implies temperature because the brightness of a star through a filter is what astronomers actually measure, and we are more comfortable with measure quantity. The VP color index is a measure of difference in brightness between a star as seen through V as blue and V as visual or yellow-green filters. This index provides us or the astronomers with valuable information about the temperature of the star.